Good morning. Welcome to today's webinar on the decarbonisation of transport and the role of standards. Thank you for joining what I hope is going to be an insightful session. My name is Nick Fleming, Head of Transport at BSI, and it's great to have so many joining us today to debate what is a complex and emotive topic. What I'll do shortly is go through some housekeeping. Slowly as you join the webinar. What I might do is just move into that now. Andrew, if you're happy to move the slides on, fantastic. So before we kick off, I just need to do a little bit of housekeeping. Firstly, to let you know that this is a listen-only webinar. What that means is you won't be able to unmute yourself or raise your hand, for instance, but we do want to make the session as interactive as possible. And so you are able to send in your questions to our panel of experts, and you can do that using the box on the right-hand side. And we invite those. We'll aim to get through as many of those as possible in the time that we have. And we'll also be running a number of audience polls throughout the day to keep that interactive feel. Upon completion of the webinar, you'll also be invited to respond to a feedback survey, and you'll be sent a recording of the webinar in due course. And finally, to mention, this is a CPD recognised webinar. So if that appeals to you, please request your certificate via the feedback survey following the webinar. Just in terms of the Q&A, as it says on the slide, to submit your questions, use the question box, which is on the top right-hand side. You should be able to see that on the top right-hand side of your screen with the little speech box with the question mark in it. Click there, your question will come through to us, and we'll try and get to as many of those as we can, as I've said. Next slide, please. Just in terms of our agenda for today, so we'll be, it's a slightly streamlined format, and we're hoping to have a slightly revised finish time. But in terms of the format, what we'll do is we're going to hear from our four expert speakers. So we have Professor Chris Smith from the University of Exeter first up, and then we'll move on to Andy Eastlake, then Helen from the CAA, Helen Ledbetter, and then finally Dr. Rui Neva from Ricardo. So what the plan is, we'll have 5 to 10 minutes presentations from each of our speakers, and then we'll move into a panel Q&A session and then do some wrap-ups. And the audience polls that I've mentioned will be kind of interspersed throughout the morning. But before we do that, before we move on to our first speaker, I wanted to do a little bit of scene setting, not so much around why we need to decarbonise our transport sector, because I think we all probably understand the contribution that our transport system makes in terms of emissions and ultimately the contribution towards climate change and air pollution, etc. But more in terms of why we feel this type of event, bringing together the maritime sector, experts from maritime, road freight, aviation sectors is important. And we are seeing in the work we do on standards, we are seeing lots of common challenges, whether that's technical challenges, operational, legal, commercial, across those sectors, lots of commonality. And with that, we're seeing opportunities for knowledge sharing and cooperation. So I think this webinar is about exploring some of these as well as what's happening within the individual modes, exploring these opportunities for the transport sector to share and learn and work together in order to have a chance to meet net zero targets successfully and sustainably. And obviously a big part of the focus today is going to be on standardization. That's the lens we have on today, really, and related tools like certification, and which we see as critical tools in enabling the transition to net zero. So a little bit about BSI, we can keep on this slide. BSI is the UK's national standards body. We are a Royal Charter organisation. We are independent of government, but we work closely with government. We develop national standards, but we are also part of the global standard system, working closely with organisations such as CEN and CENELEC in Europe, and internationally through bodies you would recognise, I'm sure, like ISO and IEC. And we represent UK economic and societal interests through those standards organisations. And actually, interestingly, we're already seeing and influencing standards related to decarbonisation of the different modes, road transport, maritime aviation, emerging through those organisations and through BSI. So it's important to note that all our standards are developed through an open consensus-based process, and that involves all stakeholder groups. In our own right, we're also a globally relevant standards organisation that has pioneered, along with UK industry and UK academia, some of the best known international standards in areas such as environmental management and safety. And we also have our assurance and regulatory services division that play a vital role in supporting organisations with compliance against those standards and testing and certification of products. So next slide, please. Okay, so just in terms of standardization, I think a key point we wanted to pull out in this webinar for those that aren't close to standards is that standards are quite a different, distinct type of intervention when compared to, say, regulation. They're very much complementary to regulation. But standards are nearly always voluntary, typically voluntary, and they're really developed as a result of the ecosystem coming together to define what good is. So if we think about markets going through transitions like this and the governance of either existing or emerging technologies, standards do a number of things to help this happen and to build safety and trust. So, there's a big role for standards in enabling the evolution of emerging technologies and their development and their safe introduction, and they play a big de-risking role there. Many of you will be familiar with standards driving interoperability and trying to bring those kind of efficiencies, cost savings into business. There's a big piece around driving resilience through supply chains that we're increasingly seeing more of with standards, and more widely promoting market confidence. The other points here I wanted just to touch on, which are very relevant today, is increasingly we're seeing standards play a role in helping businesses to implement sustainability practices and really shape how responsible businesses need to work. And all of this fits in with, as I said on the previous slide, supporting regulation and means of compliance with regulation, and that can be done through the likes of certification and testing as well. Ultimately, though, with standards, we're always thinking about, even if we're developing national standards, we're always thinking about where do we need to look at global harmonization? Where is that important to support trade and to support scaling up of new technologies and markets as well? So next slide, please. Great. So it's important we see then standards as a kind of form of enabler or lever to making these types of transitions happen. And in relation to, say, new fuels or propulsion systems, when we look at what is happening at transport, within transport, there are a number of different drivers, levers, technology pathways that we are seeing across all modes now. And thinking firstly about those, what's really driving this transition to net zero in transport. Well, we know there's a number of big policy drivers, and we know the UK on its own has set out some in the past some ambitious targets to move away from use of fossil fuels in road cars, vans, and trucks. With trucks, we're talking about 2040, which actually isn't that far away. The EU has its own climate goals to reduce 90% of GHG emissions from transport by 2050. We have the IATA aspirational goals in aviation to again around net zero by 2050, and then in maritime, the IMO similarly is really pushing to get us close to net zero GHG emissions from shipping by 2050. So, there's a lot of big policy drivers there. We have these other levers and incentives, carbon credits, offsetting and trading schemes in play to help manufacturers and others with kind of managing the economic impacts of the transition. We've seen in only this week BA purchasing 9 million, I think it was, of carbon removals credits. So that is again a significant driver here and lever to making the transition happen. Those types of incentives. When we think about enablers and technology pathways across the different modes we're going to be talking about today, there is a fair amount of commonality as well as some more nuanced perhaps routes being looked at. But thinking about the fuels and the power sources, we're seeing electrification being looked at very closely in a number of modes away from just road transport. We're seeing hydrogen in aviation. We're seeing the use of synthetic and sustainable biofuels across transport. In maritime, we're seeing, and Chris will pick this up. Chris Smith will pick this up. We're seeing ammonia and methanol and others being considered there. So there's a lot of potential alternatives to petrol and diesel, but they come with challenges. Others enablers will include, actually looking at the engineering and looking at the design of aircraft or vessels in maritime. There may be retrofitting and efficiencies that can be achieved there, but I think we are going to be looking at new systems, new propulsion systems, etc. And there's operational improvements can always be made, and that's not just within areas like freight and logistics, but that goes all the way through the supply chain and starts to pick up the circularity piece. In terms of the barriers, so I think the work that we've done within BSI, we've heard a lot about barriers coming from these different modes, but typically they're falling in around a number of areas, and this isn't exhaustive, of course, but the piece around how do we scale these technology pathways safely, but also sustainably, and we'll hear a little bit about that later from Rui in the context of SaaS, for instance. Infrastructure, we know, is a particular barrier, and there's huge costs involved in building infrastructure. But as we've seen with EV charging, it can very much delay or be one of the factors in delaying take-up if people are concerned about the availability of infrastructure. And if we translate into kind of commercial markets, we have the same effect. Price and total cost of ownership, again, we've all probably picked up on that, and certainly in terms of the kind of consumer end of the market, we've seen concerns around the price points of EVs, for instance. So there are barriers in here that we need to explore. Technology readiness and limitations is another key one. And then finally here I've put in market and investor confidence, which I think is important because that we need these technologies to attract investors. We need them to be trusted by the market, and if they're not trusted by the market, then that can raise particular concerns, particularly where we're seeing concerns, I guess, in terms of if we take a sector like aviation, might be around the legitimacy or the reliability of claims made around certain emissions calculations or certain pathways and their viability. So thinking about the various technology options ahead of us, standards will support bringing many of these into the market. And as with the barriers, standardization can potentially help to overcome some of these, although of course they're only part of the solution here. Move on, please, to the next slide. Perfect, thanks. And in our work as BSI, when we look at the standards landscape and where standards are emerging to support the transition across all of road, maritime, aviation, and rail, actually, that we don't have represented completely here today, there are lots of common challenges and themes, particularly around infrastructure and interoperability, as I've said, whether that's charging sites or refueling, safety and integrating multi-fuels into the same site, again, comes up frequently. Issues around grading of fuels, bunkering of fuels, battery manufacture and handling. Um, this is stuff that we're hearing in the work we're doing across road, across aviation, across maritime. So yeah, it's interesting how lots of common problems, and I think this highlights a number of things. Firstly, there are these common challenges in scaling or moving away from existing fuels and operations where standards can help. There may be opportunities to share, transfer knowledge, or adapt some of these practices from potentially from one mode into another. So good work that's being done in automotive, can we learn from that and adapt that for maritime, vice versa? And I guess points ultimately to where can industry actually work together? Where can industry work more closely? So hopefully we'll get on to some of those topics a bit later. Next slide, please. This was just a quick, reminder to ourselves, I suppose, of the impacts of transport in terms of emissions that we see. And yeah, I think the things I'd pull out here would be predominantly, obviously, in terms of transport sector and its contribution to CO2 emissions. Predominantly, these are coming from road transport, based on the figure on the left-hand side. But these calculations don't always take into account the energy system, and there's different lenses on this. But I think it's pretty much accepted that road transport on whole is the big contributor. But if we looked at the figure on the right and we swapped the view to a passenger per kilometre view of CO2 and non-CO2 emissions, we see a slight swap around there where aviation then shoots up to the top, which I think hopefully also helps to explain the mix of the panel today, having that kind of spread of the different modes, along with the kind of crossover in technologies that we'll be discussing. So just to recap then on what we want to cover off today, if we can move to the next slide, I'll get through this one quickly. So yeah, the real focus of today is then unpacking what is happening within each mode, and we'll hear from each of our speakers on that. What are we seeing as emerging technology pathways? What are some of the relevant initiatives, regulatory drivers and trends? Where is the market? We want to, though, explore some of these common challenges, dependencies. Where are the opportunities for cross-sector cooperation? That feels really important. What are the tools and levers that are going to get us there? And I think, obviously, given the BSI's involvement in these areas, it's really for us, we're trying to understand where do we focus efforts on standardization. So either domestically or globally, where should standards be focusing to help drive this sustainable transition? So I think what we're going to do now is move to our first. Are we moving to our first poll? No, we're going to move to our first speaker. Sorry, my mistake. Now, there is a lot of exciting work being done in the maritime sector, both to drive innovation and reduce emissions. And we need to remind ourselves again that a lot of trade is done by international shipping, and through these big international corridors. So to help us understand this a little bit better, the regulatory picture, some of these technology routes in terms of new fuels, alternative fuels, new types of vessels. Really pleased to introduce Professor Chris Smith of the University of Exeter, and also Director of the Centre for Future Clean Mobility, which is based at the university, and looks beyond maritime, by the way. It also works within off-highway and the energy and defence sectors. So I'm going to hand over to Chris now. And Chris, it would be great to hear a bit more about your work and the future Clean Mobility Centre's work, and your perspective on some of these big drivers, challenges, and the priorities for maritime. So over to you, Chris.
Hi, I've switched on my camera and my microphone, so I think we're good to go. Great. So, hi everyone, good morning. I am indeed Chris Smith, and I am at the University of Exeter, but I lead the Centre for Future Clean Mobility. Essentially, we do clean powertrains across all sectors. We don't really do much in aviation, we don't really do much in road cars, but otherwise we cover quite a range. So I'll tell you a little bit about myself, and if we can go on to the next slide, and a little bit about what we're doing And in response to Nick's questions, hopefully about some of the regulatory and technology drivers that are present in maritime, and also how that might relate over to other sectors like aviation, for instance. Okay, so we do clean powertrains, and we do it in all sorts of sectors, including those shown. If it's heavy and expensive and moves around, I'm probably interested. Most of what we're doing at the moment is in maritime, and it's a unique sort of sector, really, because it's inherently international. If you look around you where you're sat now, 95% of the stuff that you've got there around you, 95% of goods are imported into the UK via a ship. So, if you go to the next slide, please. So at CFCM, we're always trying to find, we're engineers, by the way, so of course that's what we're interested in. But we're always trying to find engineered solutions that work for a business. So the businesses that we talk to want to decarbonize, but they also want to have a business. So we are trying to find ways of decarbonizing things like these two ships here that don't stop the business from functioning. So that's very important for us. So I'll give you a couple of case studies in maritime here, just briefly to sort of show you the kind of stuff that's going on. On the right-hand side is Prince Maddock, and she's 37 meters long, 400 tons. She's pretty in the middle in terms of size ranges for vessels, and certainly vessels go up to much bigger than that. But she's quite common. She's a workboat, and she's got tools on the back. You can see some cranes and things. And she's very busy doing jobs on the seas for a variety of people. And these vessels add a lot of economic value to UK and other European countries, and we still make them in the UK. And the supply chain for these vessels is still existing in the UK. We don't make super tankers anymore. They're all made in the Far East. All the big shipping ships are made in the Far East, and that's not going to change anytime soon. So these are economically of interest to UK and Europe. And with the growth in floating offshore wind, we'll need lots, hundreds of boats like this, new boats, hopefully built in British shipyards and powered with clean powertrains. Okay, so Prince Maddock, we've been working on her for a few years. We know exactly what she does. We've instrumented her up. And so we've designed a clean powertrain. At the moment, she's got a 1 megawatt Wärtsilä diesel, so that's 1,300 horsepower, if you prefer that. But that's downrated to 3/4 of that sum. But actually, because we grabbed the data, we know she doesn't really need that. And she potters around most of the time on much less power. So she's coming alongside later this year for a clean powertrain. So she'll get a back cut open, and there'll be a clean powertrain popped in there, which is a much smaller capacity. And hopefully, she'll never have to turn her diesel engines on again. That's what we've designed it for. Not only that, she will save money versus diesel. And this is something that you don't hear often, but in maritime it is possible, in fact, to design clean powertrains that will save money. So the owners, OS Energy, clearly that's a very important issue for them. And that's one of the reasons why they're so keen to decarbonize their fleet of they've got about 12 ships. Okay, so that was funded. A lot of that was funded by Innovate UK, and we worked with OS Energy and still do. Another OS Energy ship on the left-hand side there. She's new. She doesn't exist yet. They're cutting steel for her, I think, in one of the Dutch shipyards, and she will be designed with a clean powertrain, which is our DNA, isn't it? Obviously, we're not building the whole ship. We're a university, we can't do that, but our DNA is in there. Her design will fundamentally be our design. We're helping the contractors with as much of the difficult stuff like the control systems as possible. Both of those vessels are using hydrogen fuel cells and battery systems. They're slightly different. It's horses for courses. What works for one vessel may not work for another one. At that size range, hydrogen through fuel cells, or perhaps hydrogen through a combustion engine, makes sense. As you get towards the bigger stuff, cargo, bulker type ships, tankers, then they probably won't be using hydrogen. And this is where maritime becomes a little bit different from aviation and land-based systems and rail, because we have a smorgasbord of fuels. We do already in terms of different fossil fuels. There's marine grade diesel, but there's marine grade oil, bunker fuel, etc. So we already use a variety of dirty fuels. I have to say they are quite dirty. So there's a couple of case studies. If we go to the next slide, that's what we're doing in maritime. That's fairly typical of the work we do. So everyone in maritime wants to know, well, what's the fuel of the future? Because we pretty much deal with one type of fuel at the moment, and that's everywhere you go in the world, you can find that diesel or a bunker fuel. You can pretty much find it anywhere you go in the world, and ships do go anywhere and everywhere in the world. So what's the fuel of the future? Right, this is the difficult point because for maritime, it boils down to physics constraining a lot of the choices. So we're in a physics constrained problem in maritime. You simply cannot use lithium batteries like you can in your nice electric car. You simply cannot use them on some of the big ships. There isn't enough space. You would need a second ship following behind with the batteries in to power the first ship, and that clearly isn't going to work. So and it turns out that actually the best choice for some ships is fuels like hydrogen, the smaller ones perhaps, and the best choices for other ships, bigger ones, it might be methanol or ammonia. So we've got a whole range of possible future fuels, going from nuclear on the right-hand side to battery on the left-hand side. Little ribs running around ports and harbours, we could probably do them on electric. But as soon as you get something that works, a longer period, or something that's putting out a lot more power. So if you've been, just to give you a number, if you've been on a ferry on holiday from UK to France or Spain, that ferry uses 45 megawatts of power. So these are much more powerful systems than road, and possibly even aviation as well. There's a whole range of fuels. Hydrogen, LNG has certainly become popular. That in the last 10 years, this has been a real dash for LNG. But of course, that's not zero carbon. So I'll talk more about some of the regulatory drivers in a minute, but that's not going to work in the future. We've got bio-derived drop-ins like HVO or biodiesel, and they are very attractive for maritime because 25% of the value of a ship is usually the powertrain. And who wants to throw away a perfectly good powertrain? If you can use a drop-in replacement for diesel, why not? That's certainly going to be in the transition to net zero. That's certainly going to be the case for the next 10 years or so, 15 years. But they are not zero emissions. And so when you get towards low emission and no emission, your choices collapse towards hydrogen and ammonia, which are no emission, and methanol, which is low emission. So it's 25% of the emissions of diesel. So maritime is strange in that right now nobody can pick a winning fuel. There are several contenders, but we don't. It's highly likely that we'll go forward in the future where we're in a multi-fuel universe, which nobody wants, but that's physics for you. Maersk, just to give you some facts, Maersk is the second biggest shipper in the world. They have invested, I think, 4 billion euros in methanol, and they have secured enough methanol for only a portion of their fleet. And they know within 10 years they are going to be looking for other solutions, including possibly ammonia and possibly hydrogen for other vessels. So next slide, please. That's the universe in maritime that we're living in. So the business as usual solutions for the future essentially are drop-in replacements, biodiesel, HVO. They're already well catered for really by standards, although what is a bio-derived diesel and what is a HVO exactly? Well, perhaps there is some room for standards there. Maybe they're there already. I don't know. But that world will be busy changing for the next 10, 15 years. LNG is fairly mature. We already have a lot of standards and what have you, and infrastructure in place. It's when we get to H2, ammonia, hydrogen, ammonia, and methanol, that's where we really need standards. As Nick says, standards in a way drive innovation and drive change. We don't want to we cannot in maritime get to a situation like we have with electric charging of cars in the UK at the moment, where you can turn up to a charging station and that your plug is incompatible. We cannot have this in maritime. It's an international sector by definition, and we must have harmonisation. So next slide, please. So the IMO, the International Maritime Organization, as Nick has pointed out, governs in a way ships in international waters, and of course nations have their own regulators. Like in the UK, the Maritime Coast Guard Agency, they're the rule maker, and also the police enforcer of rules in UK waters. EU is getting very active in regulating for changing fuels and against fossil fuels and carbon emissions. And UK is essentially following along in the wake of the EU. So IMO, to give you a frame of reference, is insisting upon 30% decarbonisation by 2030. This is a tough challenge for maritime, where our assets, our ships, are huge and very cost intensive. So EU is following in IMO's footsteps, and UK will follow, I'm sure, and harmonise with EU and IMO. So what are these? So that's our future. We are going to be seeing these fuels coming along now in terms of hydrogen and probably methanol, and then ammonia will follow suit. So they're good in the sense that they are low or no carbon emissions. Great, problem solved, but they come with lots of strings. So the cons, if you like, on the right hand side is we have virtually no infrastructure skills and regulate. Well, we have some regulation that is catching up for the vessels and ports and harbours. We're working with Maritime Coast Guard Agency on new regulations for new fuels on ships, but on the Port Marine Safety Code is what governs what happens in ports in terms of safety, and that is also beginning to adapt to high voltage electricity and hydrogen and methanol, ammonia less so. But so the problem is that we just don't have that infrastructure in terms of hardware and people and skills in place. I can only imagine there is a huge scope for regulatory for standardization and regulation in those areas. Hydrogen, it's a very small molecule, and it's very slippery, and it loves to escape from anything, including metal containers. So that's very difficult, and it has low energy density relative to diesel. Diesel and bunker fuel are very, very good fuels in that sense. We store them at high pressures to compensate for that. 350 is normal. 1000 bar is a bit of a dream at the moment, but that's where we're going. So clearly standardization and standards there would help. Ammonia is toxic. It's very, very unpleasant. If you've got an ammonia leak, it's somewhere in your building, you'll know about it, and you'll want to get out of the building because it is repellent stuff. There is some international gas fuels codes on ammonia, but again, more standards are required. And methanol is lovely. Ammonia's got a third of the energy density of diesel, but methanol's got half, but methanol has a flash point of 12 degrees centigrade. So this is probably why ammonia and methanol won't be making an appearance on any road cars or vehicles near you anytime soon. They're tricky. But in terms of maritime, the big ships will store tens of millions of litres of fuel on board, of diesel. So if we went to ammonia and replaced like for like, we've got vessels with 30 million litres of ammonia on board. That's the scale of the very biggest super tankers. The amount of fuel used by ships is just enormous. So different magnitude of problem. Okay, next slide, please. So the scale of the challenge, we've seen this from Nick. Thank you very much, Nick. This is all greenhouse gas emissions. Maritime is responsible for 1.7%, but the forecast is for it to grow. Oh dear! So that's why IMO, International Maritime Organization, and others are taking actions on it. That's what we've got to tackle. We don't want a sector like maritime growing in terms of this particular pie chart. Next slide, please. While we're thinking of other sectors, maritime is a big user of fuels, but it's nothing compared to, say, road cars in the UK. And it is inevitable, I think, that given the cost and scale of production of clean fuels that's required, maritime and aviation and other sectors are going to have to collaborate to get the investment into to get clean fuels manufactured in UK for clean maritime. We have the scale of the investment is just too large. UK has a clean maritime plan, and it has net zero 2050 in law, and that's not just across maritime, it's across everyone else. The sectors that we may see a new government, so we may see or may not see a revised clean maritime plan. If it doesn't come out with the word clean maritime plan on it, it will be embedded in other bits of regulation. UK is matching and catching up to EU and IMO. We will be producing regulation that is compliant with IMO or better, and we will be compliant, I guess, with the EU, because we can't have ships that are able to operate in UK waters but not Dutch or German or French, of course. So there's some, if you want to catch up on IMO, there's their plans. The figure of merit at the moment is 2030, where they want ideally 40% reduction of CO2, but they're mandating 30%. Okay, so next slide, please. Okay, so this is just a summary slide of University of Exeter, what we're doing. We work in land systems as well as maritime systems, and in power systems. So the one at the bottom there, which looks like a floating barge, and is indeed a floating barge, it's actually a restaurant near us on the River Exe. It's very beautiful, and we help decarbonize that restaurant. You can see the PV on the roof. What you can't see is the amount of batteries slung underneath that barge. So we are seeing across sectors the requirement for standardization for standards. Standards will drive harmonization between sectors, but standards must be international. We cannot have vessels unable to cold iron, which is where vessels plug into shoreside power when they're in port. We cannot have vessels cold ironing, turning up wishing to cold iron, and they've got the wrong plug, right? Or the electricity is at the wrong frequency, the AC is at 60 hertz instead of 50 hertz. We cannot have this stuff. In maritime, it's international by its nature. Okay, so there we go. Whistle stop tour of maritime and where I see standards occurring. Thank you, Nick.
Thank you, Chris. Amazing and really insightful stuff. And yeah, it's interesting what you were saying around. At the moment, it doesn't sound like there's a kind of winning fuel necessarily. So, are we going to see a spread of fuels in maritime, kind of linked to the use case or the operating domain? Is that what we think, Chris?
I've just finished paying off my mortgage, which is great. But if I had one, I would bet it on hydrogen, methanol, and ammonia. Within 10 or 15 years, we will see that those fuels being bunkered in ports in the UK.
And just picking up your point around international standards, particularly in relation to hydrogen, ammonia, methanol, and then the fuels you've mentioned. I'm intrigued in your thoughts on, the UK wants to be a leader in clean maritime. We've got ambitions to be a leader. We have to drive the narrative around standards, don't we? If we're outside the standard system, we will be playing catch up. I mean, what do you see the impact of us not having that standardization around the fuels on the UK?
So if we would see a drop off in international ships in visits to UK ports. Already, the situation is that most vessels will not bunker for fuel in the UK. They will go and do it in France, where it's cheaper. If we are unable to facilitate vessels coming in, we are the last bit of land. Well, Ireland is technically west of us, but we're the last bit of land with deep water ports before vessels go transatlantic. There's quite a lot of transatlantic trade. It would be a terrible thing if we're unable to offer. So vessels will very, very much want to bunker clean fuels before they go transatlantic and cross the Panama, etc. So they will very, very much want to pick up fuel. What a shame if we're unable to offer it. We'll still be able to run fishing boats and UK ferries in our own waters. We'll be an island, metaphorically as well as physically, in that sense. But I think we'll be missing opportunities. And also for UK shipbuilding and the supply chain, why would we want to do that and not sell our ships and equipment abroad?
Yeah, and it's critical. Thank you, Chris. We'll pick up with you later in the panel session, but thanks for now. And apologies because I was meant to run a poll before we hand it over to Chris, and so we're going to do that now before we hand to our second speaker. We're going to run our first audience poll and hopefully be able to see that. And the question is, what are the biggest barriers to achieving net zero across the transport sector? And we've pre-selected some options there: need for investment, clarification or greater clarification on policy and regulation, fuel and technology maturity, supply chain uncertainties, public acceptance, behavioural change. So if you're able to respond to that, that would be fantastic. And we can always unpack some of this later in the webinar when we get to our panel session. You can see the responses coming in. If you haven't voted, please vote. The numbers going up. So quite strong around the need for investment. So yes, around 30 to 40% highlighting the need for greater investment, particularly in areas like infrastructure, I assume. The fuel and technology maturity is also seen as a barrier. Less around supply chain uncertainties. I think what we intended there was around, say, availability of materials, critical minerals, metals, etc. And fairly low on public acceptance and the behavioural change piece as well. Okay, no, that's great. Well, I think we'll close that poll as the votes are kind of slowing down and move on to our next speaker now. And our next speaker, we've just heard a lot about maritime, and now we're kind of moving from water to road. Is that right? Water to road. And I'd like to introduce Andy Eastlake. So Andy is not only an advisor in transport around energy, engineering and policy, but also a founder and former CEO of the Zemo Partnership. So many of you will be familiar with Zemo, the not-for-profit. In the context of standardization, Andy also chairs BSI's advisory board on standards in support of DfT's zero emission HGV infrastructure demonstrator program, so the ZEHID program. And we're seeing some really interesting new projects and demonstrators emerging, looking at the likes of battery electric vehicle, HGVs, and hydrogen fuel cell options that BSI, with Andy's support, is supporting through standards. Andy, I know your experience and your views go wider than HGVs, of course, into cars, vans, low emission bus and coaches. So yeah, we're really interested to hear your views on the state of play, these challenges, what we need to do to what we're doing to help us meet these 2035 and 2040 targets, and the role of standards, of course. So over to you, Andy.
Brilliant. Thank you very much indeed, Nick. Just reflecting on the poll, I think I'm pleased to say it appears we've got a very educated and erudite audience, given that I think the media probably think that public acceptance of electric vehicles and policy might be more of a problem than we in the industry perhaps see. Very pleased to be here today and very pleased to continue to support BSI on this. I've worked for about 40 years in transport, pretty much all of that in road transport sector. And I would say that almost all of that has really been focused on trying to help develop better standards, better regulations, better certification, better incentives, and better education around lower emissions and lower carbon transport throughout that period. The first 20 years were probably focused more on the emissions, the air quality emissions, and then more latterly, for the last 20 years or so, decarbonisation has obviously been the primary arena. But if we go on to the next slide, please. I think the first thing I just wanted to touch on was how important standards are, and one of the reasons that I'm very keen to support BSI, even in my sort of independent status now and previously over many years, is how important and critical standards throughout all of their manifestations actually are to making and supporting progress, innovation, and indeed acceptance. And I think the road sector is one of the key areas where, if you like, the public are not only buying, selling, and transferring, refueling, driving, operating, all the aspects of vehicles and transport, the public are integral to. And that's not the same in aviation and maritime and rail and things, where it's quite a controlled environment and you're dealing with professionals in most aspects. So it's arguably even more important to have really good standards and collaboration when you're dealing with the public, and that's particularly the case in road transport. And just touching on a couple of points that Chris made, if we look at the road transport sector, the UK has been and remains a key player in this space. We make batteries for electric vehicles. We make cars, motorbikes, buses, very big in making buses. We make trucks here. We export probably 80% of what we make as well. And then, of course, we generate and refine the energy needed to go into those as well, and export that. So it's a key area. Automotive and all of the associated areas are a key area. But actually having good standards, as you can see here from one of the BSI slides that I've shamelessly plagiarized from another presentation, really covers so many different areas and different aspects. But if we move on to the next slide, I think one of the key things that I think is critical is about the need for collaboration, the need to develop the right standards. You need as many people around the table as possible. So if I reflect back on my early career and the need for emissions regulations, you'll probably be aware that the fuels that we use are defined by British standard, BS EN 228 for petrol, and there's a separate BS standard for diesel now. But actually going back, and the reasons we've got those standards are really actually because we have to collaborate between the vehicles and the fuels to develop the emissions regulations. So looking back in the mid-90s, one of the biggest programs that was run around Europe was this EPIFI, a European program on emissions and fuels and engine technologies. And that was really one of the first collaborations between the auto and oil sectors to really investigate how engines and fuels can work together to generate the lowest emissions possible and the highest efficiency from those vehicles, looking at many different aspects. So we've had this principle of collaboration for many years, and we've seen how that can actually begat success in innovation and in moving the dial forward. If we move forward now 20 years to the ZEHID program, the Zero Emissions HGV and Infrastructure Demonstrator program, which is £200 million worth of government funding to support zero emission HGVs and the demonstration of those and their infrastructure out on the road over the next 5 years. I think one of the key things that's really moved forward here, and you can see it just in those 4 boxes, those are the 4 projects that are running, is the range of participants and collaborators in this. So we're now not only talking about the OEMs, the vehicle manufacturers, the Volvos, Scanias, DAFs of this world, we're also talking about the energy providers, the people like GridServe, who've got the infrastructure and the renewable energy coming in there, leading projects, the high haul with the hydrogen supply into hydrogen vehicles. I think the important change here is the range of users who are actively involved in this. So in the past, years ago, it was the automotive industry and the oil industry working together, and the users of those vehicles weren't necessarily part of that collaboration. What we're seeing now is that those users are such an integral part, and as we change the technologies, we have to think about the infrastructure, the energy itself coming in, the vehicles, of course, but importantly, the impact on operations. So if you have to charge an electric vehicle for the 45-minute break, you've got to have a certain level of energy available. You've got to have a certain speed of charging. You've also got to think about where that is. You've got to think about what you do with your driver during that 45-minute period. So there's an awful lot of aspects that need to be brought together. And the more we can collaborate, the better the standards we can develop to actually move this forward. But moving on to the next slide, if we can, please. I think the road sector is one of the key areas where we are starting to see, if you like, some players win out. So in the light duty sector, in cars and vans, it's fairly clear that battery electric vehicles will be the vast majority of the solution in that. And I think we're seeing some of that certainly in the lighter truck. But a slide here that I've actually pulled out of a task force that was run by Transport Scotland, looking at the HGV sector. And we still have a range of technologies available in the HGV sector that we're considering, right from the current internal combustion engines. 98% of the HGVs on the road run on diesel at the moment. We've got a couple of percent running on gas probably, and then a handful of electric and hydrogen vehicles that are starting to emerge onto the road. But we have those different technologies. Combustion fuels and low carbon versions of those combustion fuels are clearly one of the big potential carbon savings, providing those fuels are fully compatible with the vehicles that we're trying to put them in. And that's where standards to help compatibility, both with new vehicles, but also, of course, with older vehicles, and whether those new fuels or the bio content within those new fuels will actually affect either the engine or indeed the after treatment of those older vehicles or those existing vehicles. We've then got, of course, battery electric in cars and vans, as I've mentioned, but that's now emerging into trucks. And the ZHID program will see something like 300 battery electric trucks being put on the road in the next year or so and trialled for 5 years. Another zero tailpipe emission solution is the fuel cell electric vehicles running on hydrogen, of course, with batteries and electric motors to drive them, but then a fuel cell to generate the electricity on board. And the ZHID program will see roughly 50 or 60 hydrogen trucks being put onto the road to trial in these long-haul heavy applications as well, as a direct comparison with the battery electric, both in terms of the infrastructure necessary and the standards around that hydrogen and the infrastructure, and then also around the operations and how those different technologies affect the operations of vehicles. And one of the other ones that isn't currently on the table but has been discussed and is being trialled in Europe is catenary electric trucks. So overhead wires supplying electricity in real time to the trucks as they drive up and down the motorway, a bit like the catenaries you see on electric rail. And that's certainly, they're being trialled in Sweden and in Germany at the moment. And it's got some attractive elements to it in terms of opportunities for efficiency. But of course, there's a major infrastructure, and then the standards around that would be critical. So, if you like, the openness and the choice we have available actually means we need to think very carefully about the standards we apply. And one of the key things we're doing in the ZHID program and within the BSI community that's working is looking beyond some of the vehicle aspects and energy aspects to how we operate these vehicles. So the first standard that was published under the group that we're working with was actually around the charging, the operation of the charging infrastructure in the stations for hydrogen and electric vehicles, and how, best practice on how you run chargers and run vehicles through charging stations, how you make the safety of those, how you look at the throughput of the vehicles. So it's not only about the technology itself, it's about how that operates and the interaction with people in the actual operation of vehicles, and particularly in case of this, the public charging stations. One of the other aspects we're looking at the moment is also around handling incidents. So with any new technology, the first responders and the recovery services, if there is an incident on the roadside, what do they have to do, and what do they have to do differently with new technologies, new onboard energy storage systems, be that high pressure tanks or large scale lithium ion batteries. They have to be handled differently in terms of what we do to respond to those should there be an incident on the roadside. So those are some of the areas that the community that we're bringing together are really focused on, where there's lots of work going on the, if you like, the regulatory standards and certification standards for the vehicles, but thinking about the bigger picture and in operation is really critical. And I think if we come to my last slide, I think A point I want to bring, which really brings it back to some of the comments that Chris made, is I think good standards not only make commercial sense, but they've got to make common sense. And as Chris mentioned, we need to have a common standard for plugs. So I'm in the fortunate position of having 2 plug-in electric vehicles, but because I came into this early, one of those vehicles is over 10 years old, and the other one is brand new. I actually have 2 entirely different chargers and connectors for those 2 vehicles, because we didn't have a standard for the connections on the on electric vehicles early in the process, and really that has only evolved over the last few years. So the earlier we think about this and the earlier we can agree some standardization, the more we can adopt that, and the quicker we can actually consolidate around a solution. So I've got 2 sets of chargers. Sorry, I was getting a bit of feedback there. The illustration on the right is again another key point, and particularly in road transport, we can't forget the role of the public and the importance of standards in vocabulary and standards in communication, even standards in advertising. So many of you may not be aware that there is a European standard for labelling of charge points for electric vehicle. So every vehicle that you buy, electric vehicle, is now labelled with those 2 hexagons or versions of that to indicate what standard they are compatible with, what charger you can actually plug into them. And if you look very closely, the charger there, that's the later generation one, actually has a little hexagon with a C on it to indicate. But my argument on this is that because it's not intuitive, I don't think any member of the public is really going to understand that labelling standard. So I think we can do an awful lot better than that if we're trying to make our standards both commercial sense and common sense. And I think that's really important. Think about the user throughout and bring them to the table when you're developing these standards. But very pleased to support the BSI in this work. And I think the more we can commonize and develop these standards to both stimulate the innovation in the right direction and then regulate it when we come to that point in the actual process, actually hopefully will make us leaders in this whole sector of decarbonising transport. Thank you very much.
Thank you, Andy. No, brilliant. And it's a really interesting point that you've raised in relation to what we can see now in the charging, which is perhaps an area where standardization got to this too late, actually. And as you've said, and I'm interested, the work that we've been doing, BSI has been doing as part of the ZEHID demonstrator program, I think creates a good opportunity, doesn't it, to both support those demonstrators, but actually kind of learn by doing. And there's an opportunity there for standards to evolve as we learn from real world practice. Is that what you would foresee happening? And then we create standards, based on, as you say, that shared view of those different stakeholders come together very early to say this is feasible, this isn't feasible, and this is practical or not.
Absolutely. I think there's a key role for demonstrations that, like the ZEHID demonstration, in trying to test the opportunities and the options available to us without suddenly having to put in a whole infrastructure that we've made the wrong choice about standards. So hydrogen is a great example. We have 350 bar standard for hydrogen. We've got a 700 bar standard for hydrogen. And there's now talk about transporting it at 900 bar. And then we've also got liquid hydrogen. We can't afford to have all 3 of those in play. We've got to really think about what's the right solution for these particular ones. So, and sometimes you have to go through a bit of pain, a bit of demonstration of different ones, a bit of VHS versus Betamax until you emerge to the one that will actually make the most sense in the long term, and then run with that as much as you can.
And that might be something we can pick up in the panel, because I think there's a really interesting question around prioritization of certain fuels or technology pathways to certain modes, and that tension between different modes fighting over who gets the priority. But we can pick that up later. But for now, Andy, thanks very much, and that's been fantastic. And we'll move on to our next speaker. Brilliant. I can see the slide. So, yeah, we'll move on to our next speaker. And we're switching modes again now. So we're switching over to aviation. And both of our next two speakers will be primarily talking about aviation. But first, we're going to hear from Helen Ledbetter at the UK Civil Aviation Authority. So, regulation is going to be critical to both enabling and governing the safe introduction of zero emission flight, along with other tools like standards. And so with that, we'll hit from Helen, who is zero emissions flight strategy and technical lead at the CAA. Helen leads the CAA's hydrogen challenge and is working on the Fly Zero project, researching the feasibility of bringing hydrogen into the airline and airport environment. And that will be the focus of what Helen's going to talk to us about today, the work that the CAA is doing in the hydrogen space. And we look forward to hearing more about that, Helen. Over to you.
Thanks, Nick. Good morning or good afternoon, everyone, depending where you are in the world. If we just move on to the next slide, I can talk you through a little bit about what the UK's CA's Hydrogen Challenge is. So we are doing an 18-month project looking at how hydrogen can be safely integrated into the aviation system as an aviation fuel. It's an area that is new to us as a regulator, so we need to be looking and working with industry and academia to understand where the hazards and risks are within this new technology, what mitigations industry are putting in place, and then how that impacts on our regulations policy and our certification specifications. By understanding what those gaps are, it can help us to develop policy in a timely manner. If we just move on to the next slide, we can see from there some of the current work streams that we are engaged in. So we're doing a regulatory landscape review. So we've been working with government, with industry, with academia to understand what standards are currently being used in the new technologies that are being developed, and where would they fit into our current regulatory structure. So we have a certification pathway for our current aircraft using kerosene fuel. And we believe that certification specifications works really well. The only issue we have is that it doesn't reference anywhere in there how to use hydrogen in a safe way, what standards industry need to meet to make sure that the technology is safe. So these are what we're trying to address through the Hydrogen Challenge Sandbox. So we opened our Hydrogen Challenge Sandbox back in November for applications. We were only able to accept 3. We had 20 applications from industry to work with us in this environment, and we're working with 3 of those that were successful, that were ultimately either ending in ground testing or in flight testing. So we're working with Cranfield Aerospace Solutions, Exeter Airport Consortium, and Zero Avia. And they're all looking at 3 slightly different types of technology. And by working with them and understanding their testing program, whether it's simulation testing, ground testing, or flight testing, it helps us to gather data that will help our team create policy recommendation that would then be taken forward by our regulatory teams. We've then started some hydrogen working groups. So application for these was opened at Farnborough. So we have 3 working groups on hydrogen propulsion systems, safety and certification, and hydrogen aerodromes. And hopefully our first meeting will be kicking off in October. And this is to address some of the key questions that industry had to understand how we can move the policy creation forward in a really constructive way, because at the moment we are seeing a very mix on entry into service dates. So we need to know from industry when that technology is going to be in use, and then we need to work back from those dates our policy process, because it's not a quick and easy process. It can take several years. We've also been working with universities. We have gone through and developed a list. We have at the moment of 74 questions that we feel are key to understanding hydrogen and its technology and how that can help some of our policy recommendations. So at the moment we have received funding for 2 pieces of work with industry. So we're working with UCL on hydrogen impacts on materials and design, and with Swansea University on hydrogen propulsion. And we're looking at and running different scenarios with them to understand the effects of hydrogen in these two contexts. And then the final piece of work that we're doing internally is, as a CAA, we're looking at our organizational readiness. So we call it regulatory readiness versus technology readiness. And I have a slide on that in a bit more detail that I'll go through shortly. If we move on to the next slide, we can see on there around areas of responsibility. So we're always asked, why does policy and regulatory change take such a long time? And I think it's really key for industry and academia to understand who has responsibility where. So for primary legislation, this is the Civil Aviation Act and the Basic Regulation. If we require any changes there, this requires an act of Parliament to change this. So what we have to do is we have to write down where we believe those changes need to be made, and then that has to work its way up through government, through Department for Transport, up to the legislative levels for where these changes need to be made. So for us, we can't directly make that change. It has to go and follow a government process, and that can take a minimum of 2 years or longer, depending on the complexity of the change that's needed. I think some of our initial indication is that the Civil Aviation Act is agnostic enough that it would not necessarily require any changes currently for the introduction of hydrogen. So that's good news. With secondary legislation, this looks at implementing regulations under the Basic Regulation and the Air Navigation Order. So if we want to make any changes here, the CA has to prepare an opinion and instruction to the Department for Transport, and then it becomes the responsibility of the DFT to make the actual changes in the law. And this can take a long time because we only have the option to do this twice a year, so they meet every 6 months, and this process usually takes a minimum of 18 months. And the one thing we have to be aware of is this is for any change that's needed in the aviation sector. So it wouldn't just be hydrogen. At the moment, they're looking at RPAS operations, advanced air mobility operations. So it's how do we prioritize some of these work areas to ensure that it's on the government's radar at the right time, and to ensure that those changes are put in place in a timely manner to ensure that it then doesn't become a challenge for us to certify or authorize new technologies. So the one area that the civil aviation has direct responsibility for are our certification specifications. So currently for small aircrafts, this is anything from up to a 9 to 19 seater aircraft. We look at this under CS23, and we're doing some work on that with Cranfield Aerospace Solutions and Zero Avia, because they're looking at retrofitting a Brit Island Normandy aircraft and a Dornier aircraft, so these fall under CS23. So we're working with them to understand what some of the gaps are that they're finding in our regulations, and how they can put forward special conditions that enable them to comply, even though we don't have a standard there currently. So at the moment, we're looking at each application on a case-by-case basis, whereas in future, we would like to have a very clear certification pathway. This may take many years to build because of the different types of hydrogen. It's likely that we will see these standards come much sooner for gaseous hydrogen applications, and with fuel cells, and then possibly liquid hydrogen with fuel cells. And then for combustion applications, that might take slightly longer because we can only progress those certification specifications alongside the timeframes of industry, because we're having to learn from industry. We are currently not the experts in this area on hydrogen technologies for aviation, so we're learning alongside industry to understand what that new technology is, how it operates, what the hazards and risks are, because hydrogen brings in new hazards and risks that we don't currently see with kerosene, and then what mitigations are being put in place to ensure that it is as safe as current standards, if not safer. So we're looking into all those areas, and the sooner we can understand this, the sooner we can start making regulation that's fit for purpose. If we create regulation now, it may end up that technology progresses so fast that policy then becomes redundant and is not useful to industry. So we're really keen to understand from industry some dates, we know that they move. We get that things happen along the lines and then they might be delayed, but we don't want to be in a position where everything has moved really quickly and people are ready to fly their new technologies and we won't be able to regulate it or license it or certify it because we don't understand it or we don't have the regulation in place. And I think as we've seen from Nick's introduction on standards, these are normally created by third parties such as BSI, and the CA we can choose to make them mandatory as part of an acceptable means of compliance or a guidance material. But unfortunately, there's so many advisory groups out there making standards, and we're not a member of all of these standards working groups, that we do tend to take guidance from industry to see what they're using and see how they can apply in our standards. So if we move on to the next area, we'll just go through a little bit about our policy development within the CAA. So we have 5 stages within our policy development, and this sets out various stages we need to go through. So in our stage 1, which is our capturing drivers, this is us as the Civil Aviation Authority receiving indications from industry that they are going to be using new technology. So they're new technology that's on the horizon. So hydrogen became apparent to us maybe 2 years ago. We started to collect data on this. Then as a team, we've had to define the issue, and that's how the hydrogen challenge is being created. We recognize that industry want to be working with hydrogen, so we need to define how as an organization we can support that and ensure we're there to support industry along the journey they need to get to certification. We then need to look at how we develop this policy. So we can do this through our working groups, we can do this with direct engagement with industry and academia, we do it through our sandbox activities where industry can prove in a safe environment that their mitigations work and how they can comply with some of the policy recommendations that are being put forward. Through our policy development area as an organisation, we're obliged to have public consultation on our policy development. So once we have a draft policy, this will go out for consultation with the general public. So anyone that signs up to the CA Skywise bulletins, etc., they would receive an email saying that this policy is open for consultation and they're free to make comments back. We then have to go and review all of those comments, take on board any that we feel are relevant, and also look at why, if we don't think something's relevant, why we think that's the case. Once these have all been taken into consideration, we then need to deliver that policy. So again, it goes back out as a final consultation to say this is the final policy. And then our final stages, we have to continually review that policy to see that it remains applicable and relevant. And it's particularly important with new technologies because as they change, and we see this, especially within hydrogen as a sector that can move in some areas quite quickly, we need to ensure that that policy remains relevant throughout its life cycle. And if we then move on to our next slide, this is a piece of work that we're doing internally. So it's technology readiness versus regulatory readiness. So as a regulator, we really need to understand from industry entry into service dates of technology, understand test plans, whether it's ground, like as I mentioned earlier, ground testing, flight testing, whether they've done some simulation testing that's going to support some of the safety case applications. And for us to have view of this and be available to even come down and see those tests taking place, because this enables us to go back and build within our other teams. So it's not just one person that makes these decisions, it's across many different teams within the Civil Aviation Authority where hydrogen will affect. We need to make sure that as an organisation we're ready with the correct regulations in place to support this. So if, for instance, we have someone that says we want to be flying hydrogen technology by 2028, in theory we should have started this process already about how we've gathered that data, where are the gaps in the regulation, and then we need the timeframes moving forward to make those changes needed to our certification specifications. And if there is any need for change in secondary legislation, then we need to start that as soon as possible, because as we said, it does take time to get that on the government agenda. As a regulator, we have many different teams where hydrogen will affect. We have our design and certification team, so they're responsible for initial certification of new technology. Once this has been achieved, we then have our airworthiness team that look at continued airworthiness. So how would hydrogen technologies be maintained? Do we need to have new requirements for engineers that are going to be maintaining these aircrafts? Do we need to have a new set of exams for pilots that are flying these aircrafts? How do we put forward training courses that help industry understand this new technology that's coming forward? We then have our aerodromes team that will be looking at how does aerodromes safely bring hydrogen airside, looking at working with the health and safety executive. So we have a memorandum of understanding with the health and safety executive where there's responsibilities that overlap. So the health and safety executive are responsible for storage at an airport, an aerodrome, whereas for us as a regulator, we're interested as soon as the hydrogen starts filling the aircraft, but also we need to have oversight of how aerodromes are complying with the health and safety executive regulations for storage, because it's part of the certification and licensing of aerodromes. So really important in each of these areas. And there's other areas that we haven't even probably touched on, which is human factors around ground staff that are working at aerodromes. How do they work with new technologies? Because they'll be working in probably what we would call a multimodal airport, which would maybe have kerosene aircraft, SAF aircrafts, battery operated aircrafts, hydrogen aircraft. So if you have people that are swapping between technologies, it's how do we enable them to remember what they need to do for each technology, because there's likely to be some differences. Other areas we need to look at is public perception. So there's lots of different things as a regulator we need to take into consideration. And if we move on to the next slide, it's just to say, for us as a regulator, to enable us, we need to have really early engagement from industry so we can understand what that new technology is that's coming. And even if it's something that's at really low technology readiness levels, even if it's at like TRL level 3, we really want to know about it and see how that progresses up until you're ready at TRL level 9. Because some of the organizations we're currently working with are varying between TRL levels 3 and 6. So you can see there's a vast area of data that we can collect and hopefully move forward with our policies and regulation. Sharing of information with the regulator is really important. It helps us to, like I say, understand and make sure that that regulation we put in place is fit for purpose, and enables us to upskill our staff in the correct areas. I'm sure there's many courses out there that we could send our staff on, but we want to make sure we're sending on the ones that are going to be helpful for enabling certification and licensing to go ahead. So some of the barriers that we face as a regulator is that lack of early sharing. Generally, industry only engages with the CA once they're ready to certify their aircraft. So they've been working for years on a new technology, and they come to us once it's ready to fly. So for us, as a regulator, we're then playing catch up. We're trying to learn something that industry has learned over 5 years or more in a really short space of time, with industry pushing to say, well, we need to be flying soon, but it's taking us time as a regulator to understand this new technology. So the earlier we can understand it, the smoother the application and certification process could be. The other area is unclear timelines. We know a lot of timelines are put out there for industry to get investment, which we completely understand, but we need them to be with us as a CAA to tell us this is our aim for entry into service dates, because as I mentioned, with that 5 stages of policy making that take time, we need to be able to work back from that. So if they only come to us saying that they want to, with a certification program, they want to be flying next year, we're going to have significant impact on industry being able to deliver that. And I think another area that not only the regulator face, but industry as a whole, is having skilled staff, especially in the hydrogen area. At the moment, there's quite a small skill set, so everyone's fighting for the same staff. So yeah, it's how do we enable upskilling of whether it's existing staff, new staff, how do we get this onto curriculum agendas, whether it's at universities, etc. Can we do apprenticeships? Can we do graduate schemes? Looking at how do we do that, and how do we keep that skilled workforce within the teams that we're setting up. And then what we need to understand is our key learning. So we want to look at this as an aviation ecosystem. So when I speak about it, I always speak about it as the 4 A's, which is the airline, the aircraft, the airport, and the airspace. And we need to understand how hydrogen affects each of these areas. And it might be that it affects it at different times, so that for aircraft design and certification and the aerodromes, we believe this is some of the first points that come to the CAA, whereas airspace and airlines might be slightly further down the line. Not saying that we wouldn't look at it, but it might be that we'd only look at it at a very high level, and we could do more of the detail once we know what a certified aircraft looks like and how an aerodrome has been designed to incorporate hydrogen. So these are some of the key learnings that we've identified. And then on my last slide, it just shows there that what we need is early engagement to ensure we understand these new technologies. We want to be involved in test programs and really understand what the entry into service dates are. There's the regulatory work, so we need to work based on indicated timeframes because we need to send it out for public consultation. And then we need to ensure that we deliver the regulation in a timely manner, because as mentioned, if we do this too early, it's not fit for purpose, and too late, we delay entry into service. So those are some key learnings. So really happy to discuss further how we can improve the kind of relationship that industry has with the regulator to improve the overall entry into service of new technologies.
Thank you, Helen. One of the things that strikes me, in terms of the work you're doing at the CAA, you've highlighted this is interesting territory for the CAA in terms of hydrogen because, your own words, you're kind of learning alongside industry. It's common for people to think of standards as a means of compliance with regulation. That's obviously one way that standards are used. But going back to your slide on technology readiness versus regulatory readiness, is this an area where you feel that standards can help, in terms of capturing some very kind of early stage good practices or, early stage views of what needs to happen as the regulation
Absolutely.
emerges? So do you see that as a role for standards?
Yes, I think it is a really key area. I think as a regulator, we look at what's already out there. We don't want to recreate something that's working really well. So I know there's been some standards looking at fuel hose nozzles for hydrogen refueling. I know there's a lot of work being done in the fuel cell space around standardization there. And I think it's key that what we heard from maritime and from road, that standardization is key. And the earlier we have that, we can then build on that with policy and regulation. We don't want to have two different sets of regulations, whether it's here in the UK, whether it's in Europe, whether it's in the US. We need them to be as joined up as possible. And I think standards is one of those early areas where we're seeing some key work being carried out, not just in the UK. I see it through Eurokai and SAE that there's a lot of work going on.
Absolutely. And in terms of hydrogen as a technology pathway, we know, there are concerns around the viability of hydrogen for safety reasons or from a production perspective. With the ambition to establish a domestic hydrogen route, rather than ask you an unfair question around whether you think the dates that have been suggested are achievable, I'm just interested in your thoughts on what are the key kind of enablers to establish that route that you would see from the CAA's perspective. What needs to kind of happen to be able to establish a route?
I think it's really key on that safety case. So how can industry prove that their technology is safe? And a lot of that is done through testing programs. So we've seen through some of industry working on hydrogen technologies, they've started on ground testing. They've run, let's take an example of fuel cells. They've run them on the ground. They've proven that running them over a set amount of hours that they've had no issues, or if there's issues, the mitigations they've put in place have worked. We've seen that there's been a combustion engine tested running on gaseous hydrogen that ran from my understanding, without any issues. So it worked within the parameters they were expecting. So there's lots of different stages to testing, so that's really key. You're gathering some really key data on the ground, and then industry would then can do flight testing. So they'd come to the Civil Aviation Authority, apply for a permit to fly, and these would have very restricted flight conditions. So some of it is looking at what we call an A to A flight. So it would be taking off and landing back at the airport or aerodrome you've taken off from, doing a short flight, testing some of those flight conditions that you said you're going to try out, and how you can prove that it's safe. And this is done in conjunction with the location of where that flight is going to take place, making sure it's in unpopulated areas, so that if there are any incidents, that they can land safely without causing any damage to themselves, third parties, etc. And then ultimately all that builds up to producing a really clear and concise safety case for the certification process. And then standards play a huge role in that, because
Thank you,
industry
Helen.
are using those to show compliance in certain areas,
And you've
and they're
raised a
taking
really
from
valid point that, as you said, that there are lots of standards in development from different standards bodies, and I think it's right that we take those into account, isn't it? The kind of different range of standards organisations that are active here. But that's fantastic, Helen. We'll bring you back in shortly for the panel session, and we'll leave it there for now and hand over to our final speaker this morning, who is Rui Neva, and hopefully I pronounced your name correctly there, Rui.
Yeah.
So Rui is Principal Consultant, Sustainable Transport at Ricardo. And so we're staying in aviation, but we're switching from hydrogen to the kind of big and bulky issue of sustainable aviation fuels. So SAFs, as we know, will play some form of role in helping to decarbonize aviation, and we have the SAF mandate coming in the next year. Rui has worked for EASA, the European Commission, and done work with UK DFT. He's led work for EASA and the European Commission, I meant to say. Crucially for today, he's also the program manager on the EASA EU SAF clearinghouse, and project director on their non-CO2 expert network. So Rui is going to talk a little bit more about the policy framework surrounding SAFs. What is a SAF and the definition of SAFs, their likely utilisation, and then we'll unpack some of the challenges around scaling SAFs in a sustainable way, given the impact on natural resources, etc. So Rui, over to you.
Thanks a lot, Nick, and good morning, everyone. As you can see, I'll be speaking a little bit about the policy context, and then I'll go into more details what are sustainable aviation fuels, what are the challenges associated with SAF production, and also touch a little bit on the issue of SAF sustainability, because that is crucial for the uptake of SAF. So in terms of the policies, like Nick mentioned, we are having a mandate in the UK starting next year. The EU has something similar. So starting next year, in both the UK and the EU, at least 2% of fuel uplifted in the respective airports will need to be SAFs, and this will grow quite quickly over the next 15 years. In the UK, we'll be reaching 22% of SAF by 2040. In the EU, it's above 30%, and both of these also have what we call sub-mandates for synthetic fuels, and I'll let you know what those are in a minute. But yeah, so this is crucial because although we are aiming for hydrogen in the longer term, between now and then we need to replace fossil fuels, and SAF are seen as a way to mitigate the impact on climate change derived from aviation. So they are crucial for this interim period until hydrogen comes online. So what is a SAF? SAF can be made from a lot of stuff. Currently, they are mostly made from used cooking oils and also animal fats. But in the longer term, we wish to move into more sophisticated SAFs made from such things as municipal waste, plastic, so lots of stuff, agricultural residue, algae, And in the more medium to long term, we want to have synthetic SAF. And what this means is that basically we produce hydrogen, we capture CO2, we mix it together, and we have a synthetic fuel, or also called e-fuel. And that's the ultimate goal, because this way you won't be uh, relying on anything, on any wastes, on any products. So it will be the ultimate goal, but we are very far away from there. And for now, we rely on those used cooking oils and those animal fats, especially on the used cooking oil. That's where most of the SAF produced worldwide comes from right now. What we cannot do in the UK and in Europe is to have biofuel from food crops. So you cannot plant corn or any other food stuff to make into a SAF. So we do not do that. We can also use biofuels from palm or soy byproducts, so no biofuel from palm oil. So there's no way to produce SAF. So well, we can produce SAF from that, but those are not considered a sustainable aviation fuel in the UK and the EU. So the production of SAF is standardized by an American organization called the ASTM. So they set the standards for the different production pathways based on the different bio stocks that go into making a SAF. There's currently 9 of them. You can make what's called a SAF blend of up to 50%, 50% SAF, 50% fossil fuel. Ultimately, we want to reach to 100% SAF, but that's still being developed. But in any case, it's not a concern right now, because as you've seen the previous slide, the SAF mandate is for 2% SAF. So we are very far away from having a need to use 100% SAF in all flights. So this is just a timeline where we expect things to go. So in the short term, we are using these used cooking oils to produce something called EFA, which is a type of SAF made from used cooking oil. In the longer term, we want to use those recycled fuels and alcohol to jet, using municipal waste, using the plastics, etc. And probably in 10 years, we'll be using those synthetic fuels at scale. And as I mentioned, these are made from hydrogen, ideally from renewable electricity and CO2 capture. But the big constraint for these synthetic fuels will be the availability of renewable electricity. So I'll show on the next slide, the energy needs for the transport sector by 2050, if we were to power everything with electricity, either directly on transport using battery electric vehicles, or indirectly in maritime and in aviation by producing fuels that are made with hydrogen that was made from using electricity. As those areas shown there is the land area that you would need to power all of transport with electricity, and we assumed around 1/3 offshore wind, 1/3 onshore wind, and 1/3 solar. And the area needed just to power transport would be around the same area as Great Britain. So the energy needs will be massive, and this transport is just one sector. We want to electrify aviation, we want to electrify heating, we want to electrify industrial processes. So there's going to be a massive need for renewable electricity. Of course, renewable electricity will not be the only form of electricity. We'll have nuclear, etc. We'll have other renewable electricity like hydro, but this map was just to show you the scale of the investments needed in renewable electricity to cover the demands for transport and for aviation. As I shown on the slide, around 20% of this electricity needs will be for aviation. The road transport sector is over 60%, but aviation is still a big portion of the total. And what right now we have a problem on the scaling up of SAF. only around 0.2% of all jet fuel used last year were sustainable aviation fuels. This was worldwide. Just for the EU, we'll need twice that next year to comply with the 2% SAF mandate. The UK will also have a SAF mandate. Other countries are also moving into having not as ambitious, but are having SAF mandates. So we'll have a need for uh, a massive scaling up of SAF production. And it is estimated just in the UK and the EU will need over 300 SAF production facilities across those countries. And the issue is, of course, is that right now SAF is not cost competitive with fossil fuels. It's up to 6 times more expensive. The technology is also not there yet in some of those types of SAF. We are able to produce all of them in laboratories, but to produce that industrial facility at scale, it's difficult. Ultimately, we hope that technology evolves, economies of scale come in, but there will be a need for policy to support this. In the UK, we'll have a certainty revenue mechanism that is under discussion. It was part of the King's speech earlier in July, and what that means is that there'll be a cost. For example, if there's a guaranteed strike price, which is one of the options there, there will be a subsidy if the cost is too low, and the producers will pay into a pot if the price is too high. So it gives a minimum floor for the price, so that investors have the confidence that they'll be able to invest, that they'll be able to recover the costs into the future. And besides all of that, all the need to scale up production, there's also concerns about the sustainability of SAFs. Um, uh, Next slide, please. It's not working. Next slide. Sorry, it's the one called sustainability. Yes, that one, please. Thank you. So there's serious concerns about sustainability of SAF in some places. And now I have control again. Thank you. And this is because of issues about greenwashing. There's concerns that, as I mentioned, most of the SAF comes from used cooking oil right now. There's some concerns that some of that cooking oil being used is not really uh, used. It's virgin cooking oil, so it's never been used before. That's of course not ideal. We have in the UK just recently the Virgin Atlantic was banned from saying that it was a sustainable aviation fuel used on their flights because that risks misleading consumers. So for this, certification sustainability will be crucial. There are efforts right now to make sure that all stuff that's being used is actually sustainable, and this will be going into the future and will be very crucial to achieve not only the goals on the mandates, but also to ensure that the public is on board with the use of SAF, and this is not seen as just greenwashing by the aviation industry. Um, and as Nick mentioned, I'm the program manager of the USAF Clearinghouse. This is just one of the several initiatives across Europe, across the UK, across the world that are trying to help SAF uptake. In this case, the USAF Clearinghouse promotes both the certification of SAFs, so using those standardized pathways, we help excuse me, we help fuel producers in the certification process so they can comply with the standards. It's a very complicated process because of the issues around safety. So everyone is keen that all SAFs are the same as fossil fuels in terms of safety. So it's a very complicated process. Excuse me. So we are helping producers, and we are also producers on the sustainability certification, so they can show that the SAFs actually reduce emissions in the and can be used to reduce the global warming impact of aviation. Thank you very much for your time today.
Rui. Thank you, Rui, and hopefully, you've got a glass of water to hand there. Rui, just a quick question for you, if I may. I think you've talked about the sustainability of SAFs, and I guess that's one of the biggest questions, isn't it? Or most common questions that seems to come up when we're talking about SAFs in terms of, are they truly sustainable? Is that an area where you can see standardization, perhaps? So the standards currently that we have are very much focused on the physical properties of SAFs as a fuel.
Yeah.
But is there a role for standards there in supporting the kind of broader supply chain and production of SAFs that you're seeing?
Indeed. So the as you mentioned, the main standard from ASTM is about the physical properties. So to make sure that SAFs are the same from a chemicals perspective as fossil fuels, so you can just put it on an aircraft and it's the same and it will be safe. So that's the main goal. But there's of course a strong interest on the sustainability assessment and standardization, and the standards will very much play a role in there. Um, and on SAF, this certification needs to be on a life cycle assessment basis, because burning up on an aircraft, the CO2 emitted will basically the same, minus plus a few percent. It's the same, but on a life cycle basis, you are not introducing much more CO2 than already existed in the atmosphere. So there's lots of different works going on. The US just published a few months ago the proposal for standardization of excuse me, of the sustainability assessment. IATA just published, together with the RSP, their view on sustainability assessment. So yeah, so standards for sure are needed worldwide. And yes, it's something that will, in the next couple of years, that the SAF mandates start to be implemented, there'll be strong interest in that. And also because of the issues around the use cooking oils and risks of fraud there, of using new cooking oils instead of used. So there'll be a strong interest on that area, and standardization bodies will for sure have a role to play.
No, brilliant. Thank you, Rui. We're going to open up into our panel now. Before we do that, or while we'll do that, I'm just going to ask my colleagues to help us run our second poll of today, which kind of links to what we've been discussing with Rui around whether we're prioritising the right fuels to the right mode of transport. So interested in views on this. An example of this may be where we're using biofuels in road transport. Is that the right place to be focusing efforts on biofuels? Is electrification the right focus in maritime, for instance? But yeah, interested in thoughts on that if you have them, and we can maybe pick some of that up in our panel session. I'm also acutely aware that with some very poor chairing on my part, we're massively overrunning. So we're going to aim to finish at midday as originally planned, not the slightly more streamlined 11:30. So interesting, spread of views here, which we kind of anticipated. And it is a complex issue, and we're still trying to understand which pathways are viable around those given use cases and operating environments. But broadly, I think a little bit nudging towards people agreeing that we are prioritising, which is helpful. So what we'll do now is move into our panel session, and I'll ask our speakers to turn on their cameras, and we'll kind of stay in panel for about 15 minutes and then go into a wrap up. So it's a slightly condensed panel session that we have. and I'll start to pick up some of the questions that you've sent in. To kick off, yeah, and building really on that, on the last panel, the last poll question, I suppose, is that each of maritime, road, and aviation are on their own pathways in terms of the technologies available. So how do we see that demand being managed in terms of those different pathways? We can't all go down the same pathways. So how do we prioritize or manage that demand? And using the example of sustainable aviation and biofuels, for instance, I don't know if anyone had any initial thoughts on who gets the fuel that's most is the highest TRL, who runs with that.
Yeah, I'm happy to chip in, Nick. I think obviously biofuels has been a key play in the road transport sector. We've got 10% ethanol, renewable ethanol, bioethanol in gasoline now, in petrol, and 7% biodiesel. I think one of the things we need to do is to generate as much production capacity for those biofuels as possible. I think ultimately we do think those will move out of road transport. That's definitely the case, that they'll be in play, but they're a great way of decarbonising the existing fleet. Road is, as we heard, 80% of the carbon from transport at the moment. So a rapid decarbonisation of that road sector with the legacy fleet, if you like, with the bio and renewable fuels, whilst we then transition those into the really tricky spaces to decarbonise. And I'll put aviation in that. There's certainly some real challenges trying to do hydrogen or electric in long haul aviation. So sustainable, renewable fuels and the resources for those. But it's the area under the curve. So can we decarbonise as much as possible of what we've got today as quickly as possible, whilst we start to change the fleet and change the technology and all that sort of thing? I think that's a key area. So certainly I think we are, as an industry, we're conscious of that, but let's generate the demand for what we've got and generate the supply side as much as possible right now.
Thanks, Andy.
I think I'd just like to add that. So for aviation, we're, as a regulator, we're fuel agnostic, so we're led by what industry wants to do. But I think some of the early indications are to us it's going to be a mixed fuel that's being used. So some will use kerosene, some will use SAF, some will use battery, some will use hopefully hydrogen. But I think for aircraft that are in that mid to long haul area, I think from the indications we're seeing from industry, hydrogen seems to be one of the better options, purely because batteries currently are too heavy to do long haul, and ammonia, there's too much NOx with the weight. If you'd need to put on to have like scrubbers or something to take down that NOx pollutant, is probably not practical for an aircraft. So we see it as one of many options depending on the size of the aircraft.
Not sure, Chris or Rui, if you had anything to add. Please come in, Chris.
There's a couple of issues here. One is about well, the first one is probably the issue about, well, what do we want to do as a nation in terms of, if there is a scarcity of bio-derived fuels, which I think there probably is, we're not thinking about it being possible to shift all transport to biofuels. So if there is a scarcity of it, do we want to let the market settle who buys, who's supplied with that fuel, or do we want to have a look at, say, important transport functions like growing crops in fields, because we all eat, right? Do we want to, say, reserve some bio-derived fuels for agriculture? What about search and rescue on the sea, and actually ambulances and fire engines and police cars, whatever? And so we might as a nation want to say, well, hang on a minute, we're going to supply these sectors here, these particular kinds of things with these fuels because they're important to us for some other reason. Yeah. I don't know if anyone knows what I did hear something about domestic aviation accounting for 66% of all agricultural land in the UK if we supplied only domestic aviation with that. So I don't know how scarce bio-derived crops are going to be. Perhaps someone else does.
I think there's a key issue about availability, without a doubt, Chris. But this is where some of the standards, and having really good standards of sustainability, land use change. I think it's an area where UK is really sort of leading the way. We've got some really good standards for our renewable fuel transport obligate, the RTFO. But there are still questions about some of the sources of some of the fuels that we use. So that particularly is an area where the standards of sustainability leading right up the supply chain are going to be critical, and UK can lead the way.
And building on that, if I can, Andy, the UK leadership opportunity piece, interested in the panel's thoughts on where the UK can seize the kind of economic opportunities of what we've discussed today, and what is the role of kind of standards in kind of supporting our international ambitions. Sorry, Chris, did you want to come in on something else there?
I had a point about hydrogen and the idea of putting 20% down the domestic gas network. My understanding is if that decision is taken, then transport, all of us here can probably kiss goodbye to our hydrogen supply as a fuel.
Okay, no, thanks, Chris. That well made point. And yeah, so the piece around leadership, which I think has been touched on in a number of the presentations, where when we hear a lot about UK leadership, how do we kind of seize that opportunity, I suppose, in this field? So, Chris, you made some really interesting comments about the maritime sector, where we have a supply chain, and we still produce some of the vessels, but just interested in what the panel think of that as a realistic ambition.
Yeah, happy to chip in again. I genuinely think we've got, and this is where having good standards, good education, good media, and the public engagement really helps. If we've got a community and a user community that understand what we're trying to achieve and are on this journey with us, it's a lot easier to work with us. But we've led the way in, for example, the standards around low emission and zero emission buses. We had some of the most advanced approaches to that, looking at a well-to-wheel basis, whereas everybody else was looking at tailpipe, for example. We are certainly, and Ricardo, actually, I will credit the Ricardo team with a lot of the really good thinking about life cycle analysis of vehicles, which is coming in. European Union are pushing for a life cycle analysis approach. So that starts to look not only beyond the tailpipe and the well-to-wheel, but also at the embedded production emissions. And all of these things, I think this is where the UK, I genuinely believe we've got some of the best thinkers, and if we've got that, we can start to work those standards and export standards and the approaches as much as we export physical matter and things. So again, like I say, I know Ricardo were actually tasked by the European Union to look at a life cycle analysis approach for road vehicles, which is purportedly going to come into play in 2025 and beyond, I think. I think I would say that, as I say, our RTFO, our renewable fuel transport fuels obligation, is some of the most robust regulations, and I think my understanding is that our airline industry are at the front of some of the international standards around sustainability. So I genuinely think we've got a community, an appetite, a public that kind of get this. You might not think it from the media sometimes, but actually there is a public that gets this whole climate change and actually will support the development of standards and trying to lead the way.
No, thank you, Andy. I don't know if anyone else wanted to come in on that point. Chris, please.
I don't see why we can't grab a bit of the bit of the pie for UK internationally in this. People, when I talk about chances of growth in the maritime sector for UK versus Netherlands, Norway, etc. People always point out that there's no domestic diesel engine production anymore in maritime in the UK. It used to be, but there isn't now, and we're declining power. And then I look at the powertrain, the actual gubbins that goes into a clean powertrain versus what goes into a diesel, and they're completely unrelated. So who cares where diesel engine manufacturers now? It doesn't make any difference because it's a different business. There's a different people, different skill set. They're going to be making the clean stuff than it is doing the diesel. So why not? If we get our regulation in and standards in place, and we get a demand signal from government, which is critical, and the regulation to support that. So all government assets, maritime assets, will go clean by such and such a date. Other people will be buying our stuff because we'll have a lead, and that's a good thing. So we could do it.
Thank you, Chris. Thanks. One of the poll, our first poll, alluded to, I think, the fact that perhaps the public acceptance issue is overplayed. I think, Andy, you've mentioned that a few times already this morning. One thing that is, I think, again, has come up is the kind of cost that's attached with decarbonising. And I think, Chris, you mentioned earlier in terms of some of your work that businesses want to decarbonise but still have a business. And I think if we're Andy, thinking about the road freight sector, we know total cost of ownership modelling sometimes is slightly scary for operators, and Helen Rui in the aviation sector. We've seen research that says consumers might be willing to pay more for sustainable flights, for instance. So I'm just interested in the panel's thoughts on, is business willing to pay more for decarbonisation? And is that, Andy, to your point, is that often overplayed that the public are concerned about the costs to the end user ultimately?
I think, yeah, some businesses are prepared to, even in the freight sector, we are seeing some of the sort of blue chip businesses prepared to pay a little bit extra to decarbonise their deliveries, to pay, HVO, a lower carbon fuel in diesel trucks, costs more, and some people are prepared to pay for that. A lot of people in the freight sector, as you mentioned, are working at very, very tight margins, so this is not easy. And electric trucks are more expensive, and hydrogen trucks are more expensive again. So yeah, there's lots of challenges there. I think converse and consistency of government direction and policy is critical. So we've had a pretty good progress on electric car uptake, and then that was really disrupted by the perceived rollback last September on the phase out dates. So that consistency of long-term direction is really important. And then, just anecdotally, I'm sat here in Buckinghamshire, Bedfordshire, and one of the main routes is underwater. 2 meters of water has closed the A421 just down the road from me, and that's a climate change aspect. So it's here, it's now, and I think people are seeing that, and it's affecting everybody around the UK and around the world. So we need the media on board, and we need some more sort of direction around this. But climate has to be it is our number one issue in the near and medium term. So how are we going to play that? And I think having a government that gets that, there is going to be costs. There's going to be costs to people, and we've got to accept that. But if we don't do it, those costs are even greater. And if you look at the Committee on Climate Change narrative, the GDP costs to actually get to net zero by 2050 are significantly lower than the costs that we'd incur if we don't get there. So, we're all on this messaging mill as well. But it's important that we keep going.
Anyone else like to come in on that one? Chris, please.
Sorry, Rui, do you go next? Because I keep making my mouth go. Go on, I'll let you.
Yeah, so in aviation, the industry will not have a choice but to start using SAF. It will require a month for starting next year, and it's likely that almost the cost will increase, and they'll have to pass some of that to customers. So we'll have to see the impact. The industry has grown so much in terms of the number of passengers that even if there's a small potential reduction, I don't think there's a risk of the industry becoming smaller because of this, at least while the percentages required are very small, and when they are bigger, hopefully the price parity will be closer. So ultimately, I think people will realize the need to pay for this, and I don't think there'll be massive impact on demand. I know for some that's concerned because they would like to see demand to be reduced on aviation, but I don't think just the need to use SAF will be enough for that to happen.
No, thank you, Rui. And Chris, did you want to come back in on that one?
Yeah, I realise I've got a few seconds before we finish. So when we say more expensive, what we really mean is more expensive than diesel. Government can take that off the board, that comparison, by just banning diesel. Banning to just say, by this date, no more diesel trucks. There you go. So your electric and hydrogen trucks are just what they cost. Issue then is how you build that into your business. There is hope over the horizon. One of the ways of supporting such things is with subsidy. We can look at another sector that has had subsidy for many years, which is wind power, and it works. Wind power is now cheaper than gas, so we can do this. We know we know the way to do it, and it's just a bit of government will that's required to get it underway.
No, thank you, Chris. And in the interest of time, I want to just push one final question out to you, and it kind of follows on, I think, from what you were just saying there, Chris. Is from your respective modes, thinking, about aviation, maritime, road, in particular, where do you see the opportunity? Where are you seeing the kind of opportunities for cooperation? From what we've discussed today, where are you seeing the opportunities to kind of share knowledge and transfer? Is that something you think is helpful to learn across the modes? I guess another way of answering that question would be, what can be learned from each other's sectors, good and bad. We've talked about the EV charging points and how everyone's trying to avoid that happening in their modes, but are there any other thoughts on, what can be learned from the sectors before we wrap up?
I think for us in the Civil Aviation Authority, we have found through launching the Hydrogen Challenge, we found engagement across industry, academia, and other regulators been to be really positive. And we're still at a stage, I think, in the development of hydrogen where people are willing to share that information. I think once we get closer to entry into service dates and people wanting to be, or industry wanting to be first to market, that's when maybe not so much information will be shared. But at the moment, I'm seeing it as really positive, and I think we can only build on that and move forward. And I think in the UK, there's a huge push towards it. I think where we need to improve further is that international collaboration and ensure we have like harmonization and standards and things like that. But definitely at the moment, I'm seeing a very high keenness in and willingness to share information and learn and upskill.
Thank you, Helen. Final thoughts, Andy?
Yeah, one of the things I've liked about Zemo Partnership was the broad church and the collaborative approach that we brought, and the fact that we had everybody who had some skin in the game around the table, you never stop learning, and you're always getting new perspectives coming in. Now we are seeing more and more of that collaboration going on, more sharing of information. The thing that holds us all, brings us together is this climate change objective. And even though, what you might think are competing companies or competing perspectives, they actually all come together and support that. And I think it's, it's a really exciting time to be in this. And, just as a plug, we, BSI, have just published a couple of standards. Getting the feedback from the broadest number of people on those is really critical. So please engage with this. Anyone who's on the audience on the call, engage with that feedback in, because there's nothing like having a broad range of perspectives.
No, absolutely, Andy. And Rui, Chris, any final thoughts from you before we close?
From me,
Probably there's a lot to be gained from cross-sector collaboration on fuel production and storage and handling, because we're after hydrogen is at the root of most of what we're talking about, and electricity, and that's got to be international as well.
Yeah, there's a lot of commonality across those, navigating those safely, I think, that we're seeing. That's fantastic. Just like to thank all of our speakers and panelists, and thank them for their time and patience of staying on a bit longer than we'd perhaps discussed, but that's been really, really insightful. All of our speakers stroke panelists are happy to be contacted, and I know that the email details were shared in the slide packs. We were planning to run a third poll, but I think I'll leave that for now and just go straight into sharing, to Andy's final point around getting involved in standards. You'll see some contacts across BSI here that work in the transport team. So Matteo Novati heads our road freight work, the work that Andy's involved in, and you can contact Matteo if you want to be involved in the work we're doing around the electrifying trucks and the charging infrastructure piece. Chris G heads up aviation, anything to do with the work we're doing around air mobility, but also some of the stuff we're looking at on SAFs and wider sustainable aviation. Please contact Chris. Abby Dorian is our expert on battery development and has been involved in the Faraday Battery Challenge. So please reach out to Abby if that's of interest. And my colleague Rajesh Kunga is our kind of in-house lead on EV charging and everything that comes with the charging infrastructure. So please reach out to us. There are some other webinars running later this week for those that wish to join those. We've got one this afternoon on net zero planning, that's specifically for SMEs, and then tomorrow on the 26th, net zero and nature positive session around food systems, which is again both free to attend webinars that you can find further details by following those links. Also, just to point you to, we don't have the link in the slide here, but please come and have a look at the BSI. So we have an automotive showcase page on LinkedIn, we have a mobility page showcase on LinkedIn, and that's where you'll find all the links to the different standards that we're currently working on, that Andy has mentioned, for instance, and any of the work we're doing in support of aviation, maritime, and road transport. We tend to populate those LinkedIn pages and those social pages. We tend to send out links there. So please reach out to us if you want to get involved in any of the standards work that's been touched on today, or if you feel there's an area where we should be focusing in standards that where we're not focusing. We'd like to hear from you on either of those points. But just to bring it to a close then, and thank you for running 5 minutes over the original scheduled cut-off point. Thanks finally to our speakers, Rui, Andy, Helen, and Chris Smith, and hope you have a great rest of your Wednesday. Thank you, everyone.